So, anyone remember what a central angle is?
The vertex of the angle is at the center.
Okay, so in a central angle, the vertex of the angle is the center. So in this case, we have angle AOB is our central angle. If I told you that AOB was, I don't know, let's say 80 degrees, what did we know? The outside arc. So if angle A, whoops, forgot the A. If angle AOB equals 80 degrees, then the measure of arc AB equaled 80 degrees. So they were the same. Okay, when we come over to inscribed, your vertex of the angle is on the circle. So what would be the inscribed angle for this one? So where do you see a vertex on the circle? C. So angle ACB is an inscribed angle. So instead of that vertex being on the center, it's on the circle. Also, if the arc AB is 80 degrees, then, got the N over here, angle ACB is what? Not 280. We're talking about the angle, not the arc. If we were talking about the arc ACB, you're right, it would be 280. But the angle for inscribed, it's half. So if the arc is 80, the angle would be 40. So the main differences, inscribed is half of the arc, and the vertex is on the circle. Central, on the center for your vertex, equal to your arc. Okay? So what we're going to be looking at today are different kinds of angles, and you're going to have these two mixed together within a problem to where you might have to use a central angle to help you find an inscribed angle. Okay? So, our three examples all have to do with finding different parts, whether it be an arc or an angle. So in the first one, we're trying to find the values of A and B in the picture. Anyone think they know where to start or a place to start?
The parallel lines.
They're not parallel.
Vertical angles, right? Doesn't 60 go intersect?
The 60 belongs right here. What kind of angle is the 60? Is it a central or is it an inscribed? It's inscribed because Q is on the circle. So if we follow the lines out, I get here and here. So then what do I know about this arc right here? It's 120. Because this is half of the arc. So this is, if you follow the rays of the angle out, you'll get what's called the intercepted arc. That's what your inscribed angle is half of. So A would have to equal 120 because this angle here is 60. Now if we do the same thing for B. So B, if we follow it out, we get from here to here. So do we know what this arc is? It's 150. So for B, we're looking for the angle. So if this whole arc is 150, what is the angle? 75, half of it. So 150 divided by 2, which is 75 degrees. These are the things you're going to be looking for in your problems today. You're going to be looking for inscribed angles, and if it helps you to trace out your angle to figure out your endpoints so you can see what your arc is, then do that. Okay, what about the second one? What is the measure of angle A? So if we follow our lines from the vertex of A, how big or what does that arc measure? How do you know it's 180? Because it's a semicircle. This is a diameter going through the center. So we know this is 180. So what does that mean angle A has to be? 90. And that's something that's true for all circles. When you have an inscribed angle that intersects a diameter, this is always going to be a right angle because of this inscribed angle rule. Okay, what about the last one here? Again, we're finding A and B. So A is the arc from here to here. How might we figure out A? Chase?
360 minus 60 minus 82.
So 360 minus 60 minus 82. So we know the whole circle has to add up to 360. So if we subtract the two that we know, what do we get? So what's 360 minus 60 minus 82? 218. Okay, so if this is 218, how does that help us find B? It's half of that, because B is the inscribed angle that intersects arc A. So what's half of 218? 109. Okay, any questions about inscribed angles at this point? Ryan?
So will B always be half of A?
The inscribed is always half of the intercepted arc, yes. That's the definition of inscribed. Just like central is always equal, inscribed is always half. Chase, don't put that in your mouth, please. Any other questions about inscribed angles at this point?